Hi guys, Mrs. Warner here. Ready to do some perfect squares and perfect cubes. Okay, so first we have our table of squares at the top. I already filled them in for us because that would be a waste of time sitting here squaring all these numbers, which you guys already know. If you need to fill them in also, you can get them off the completed note sheet. Okay, so we're going to start with taking the square root of 18. So I wrote out the steps for us here. And we're going to follow those step by step. So the first thing we're going to do is we're going to look for the largest perfect square factor that divides into each radicand. And the radicand is the number underneath the radical symbol. So 18. Well, 18 on the chart falls between 16 and 25. So I'm going to say to myself, does 16 divide into 18? No. How about 9? Does that divide into 18? And sure enough, it does. So 18 is going to be broken down into radical 9 times radical 2. 9 times 2 is 18. And the square root of 9, notice I wrote the perfect square from the chart first, is really a 3. So this becomes 3 radical 2. There is no square root of 2, so we leave him underneath the radical symbol. If I didn't pick the largest perfect square factor to begin with, the number underneath the radicand might need to be broken down again. But in this case, I did a good job. Let's look at 80. Okay, so I'm going to say 80 falls between 64 and 81. 64 doesn't divide in, 49 doesn't, 36 doesn't, 25, but 16 does. Jackpot. So 80 is 16 times 5. And sure enough, the square root of 16 is 4, so it's 4 radical 5. Oh, somebody put a negative 3 in front of radical 45. If you look up at the top, it tells us if there's a number on the outside of the radicand, we are going to multiply this by the perfect square factor that comes to the outside. So 45 falls between 36 and 49. 36 does not go in, 25, 16, but 9 is my perfect square factor. So I'm going to go negative 3, radical 9, radical 5. 9 times 5 is 45. Now, the radical 9 is a 3, and negative 3 that's on the outside is going to multiply. Multiply, not add, folks, by that 3 that just came out. So now this becomes negative 9 radical 5 for my answer. Somebody put a half there. Okay, so I'm going to do a 1/2. And the 56, that's got to have a perfect square factor. I don't think it's any of these larger ones, but I do know 4 and 14 divide into 56. So now I'm simply going to do 1/2 of the square root of 4, which is a 2, and then it's radical 14. But half of 2 is just 1, so really my answer is 1 radical 14, or just radical 14 for my final answer. That was fun. Let's move on to some cubes. Now, perfect cubes are numbers like 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So the cube root of 8 is the number 2. 2 multiplied by itself 3 times gives you 8. So let's look at our first example. See the little cube outside the radical now? See there's a little 3 outside there? That means take the cube root. So I'm going to look on the chart. Is 64 on there? Look at that. There it is. The answer is 4. That was easy. Okay, now 54 falls between 27 and 64. So I'm going to first say to myself, does 27 go into 54? And sure enough, it does. So I'm going to do the cube root of 27 times the cube root of 2, because 27 times 2 is 54. Now, if I look up on my chart, the cube root of 27 is 3. So then it's 3 cube root of 2 for my answer, because the cube root of 27 is 3, so he comes to the outside. Same idea as before. If there's a 2 out there, I'm going to look now to see what perfect cube goes into 24. It's got to either be 8 or 1, and sure enough, 8 goes in there. 3 times. That's an 8. So the cube root of 8 is really 2. So this is 2 times 2 cube root of 3, or 4 cube root of 3. Great. 128, looking on my chart, that's 64 times 2. So now the cube root of 64 is 4, so that's 6 times 4 cube root of 2, or 24 cube root 2. Not bad. Cubes are a little different, though. You got to think of your perfect cubes instead of your perfect squares for your factors. Okay, now, what if there are some variables underneath there? That's not that bad at all. So like say it was the square root of x to the 6. All you're going to do is take the 2, which comes from the square root, divide it into the 6. How many times does it divide in there? 3, kind of like we're doing long division back in 4th grade. And it has a remainder of 0. It divided in evenly. So the square root of x to the 6 is just really x to the 3rd. It's how many times does 2 divide into 6? What if it was square root of x to the 7th, though? 2 doesn't divide into 7 evenly. It goes in 3 times, but there's a remainder of 1 left over. Well, that's okay. That means that x to the 3rd comes to the outside, but that remaining guy stays underneath. Whenever there's an odd power, there'll be one variable left underneath there. Same idea when you're taking a cube root. You're going to take, this time, instead of dividing by 2 for the square root, you're going to divide by 3. 3 goes into 6 2 times, so the cube root of x to the 6 is really x squared. There was no remainder. But if I had the cube root of x to the 7th, 3 divides into 7 2 times, and there's 1 left over. So this is really x to the 2nd, but there's a cube root of x left underneath because there was a remainder of 1. All right, let's try a couple of these. Let's look at example 2 here. For these other examples, we can look on our note sheet and fill them in. So -3, we're going to do a square root. 24, my perfect square, is 4 and 6. And then I'm going to take each of these powers separately, and I'm going to divide them by 2. So I'm going to break them up into separate radicals. Okay, so now I have a -3. The square root of 4 is 2. That's really -6, correct? This radical 6 has to stay underneath there. Now, say to yourself, since I'm taking a square root, how many times does 2 divide into 4? 2 times. How many times does 2 divide into 2? Once. How many times does 2 divide into 3? 1 time, but there's 1 left over, so he goes underneath. Let's try that same idea with a cube root. We'll look at number 4. -3 cube root. Now I have to think of a perfect cube that goes into 40. I know, 8 times 5. And then I'm going to take the cube root of x to the 6. Okay, the cube root of 8 is really a 2. There is no cube root of 5. And when I take the cube root of x to the 6, 3 divides into 6 2 times. There's no remainder. So now this becomes -6x squared cube root x to the, or to the cube root of 5. Sorry. So if you'd like to see these other 2 examples, you can look at them in your note sheet. They're already filled out there for you. All right. Enjoy. Happy homeworking. Bye, guys.